There we go. I'm going to do one more quick brief video. I don't know whether it's really necessary or not. I guess I mentioned that those little bolts right there that I was showing you, I'll get the flashlight out again. Those little collimating bolts, I'll zoom it out a little bit. Those little collimating bolts right there, you could see a really good view with them right there. My hand is not very steady holding this camera, but you can see the bolts right there. When you loosen the bolt on the right hand, if the coma tail was sticking out toward the right in the star image, you had to loosen the right hand bolt, and that would tend to reduce the length of the coma tail. Okay, and also the same thing for the other two screws. The direction of the coma tail indicates which screw you loosened. So they were coordinated almost perfectly with the direction of the coma tail and the eyepiece. Okay, I thought I'd mention that again, just to let just to sort of reinforce what I was saying before. Now I'm just going to back that off a little bit. Okay, turn the flashlight out. So anyway, I thought I mentioned too that I have another device for this that I'm thinking of trying. This device is capable of holding a binocular viewer. And one problem with that is it's heavy and it sticks way out. And these little screws right there, I'm not sure whether I can tighten those well enough just with my fingers to keep a really heavy object out in front of that from shifting up and down. It might just flop over on me unexpectedly. So I'm a little nervous about using the binocular viewing device on that. What I might do is use it with the 45-degree prism that came with this telescope and use it that way. That might be, and then I could have the binocular viewer coming straight back. I've actually done that before. And this telescope has a huge back focusing on it that it can actually use the binocular viewing device at low power as far as I know. So if I put in two eyepieces, like 1-inch eyepieces in there, that will give approximately 50 power, like 225 millimeter, and that will allow me to do low power viewing with this telescope with the binocular viewing device in place, and it would be very good for looking at galaxies and star clusters at low power. This is equivalent to having a really good pair of high power binoculars. It would cost a lot of money. So just by switching this to a binocular viewing device, all I do is take those out, put the 45-degree prism in there, and put the binocular viewing device in there. You can use different eyepieces in the thing. I bought a really good binocular viewing device for not much money. I think it was on sale. It's the Orion binocular viewing device, and they have an expensive one now, but I found that for my purposes just the inexpensive one was just fine. I think it was a little over $200 Canadian that I paid for it, and the thing is awesome. It is just really good optics in it, just amazing. And I think you might notice a slight degradation in optical quality with the 45-degree prism if you looked at the planets with the binocular viewing device. The reason for that is that even though I think the prism that came with this is extremely good quality, there's nothing wrong with that, but having any type of prism like that automatically introduces a small amount of image degradation. Not very much, but you have to have very accurate optics when you're looking at the planets, and well collimated if you want to see details in them. When I was looking at the planets with this, I could see all kinds of markings in Jupiter's cloud bands. As far as I could tell, I could easily see the disk shape of at least one of Jupiter's moons. I could see the Cassini division in Saturn's rings very easily with this. I could see the central cloud band of Saturn just beautifully with this telescope. The rings look so beautiful that they almost look surreal with this telescope. One of my neighbors looked at the moon through this and she said, "That is a NASA quality image right there," she said, looking at the moon with that telescope, right with that eyepiece. So that's how good the optics are in this thing if you get them lined up right. So, by the way, other Schmidt-Cassegrains have similar problems with collimation. Like if you buy a C8 or a C11 or a C14, eventually you may have to collimate the thing or else get an expert to do it. The collimation, if you're careful, should be permanent, more or less, unless you bang the thing around a lot, which can happen if you put the telescope in a car and transport it out to a dark observing site to get away from city lights. So anyway, this telescope, by the way, as I mentioned, is also very good for deep sky observing. I haven't done too much of that lately because the planets are so good. By the way, this summer the planets have been spectacular. I thought that I was able, on the planet Venus this year, to see some slight shadings in the clouds on the planet, which is not that easy to do. During the dust storm on Mars, I was actually able to see the polar cap and a large, complicated dark marking on Mars right through the dust storm with this telescope. I saw a little white oval spot and a dark spot in Jupiter's cloud bands as well, a very small one, as well as 3 or 4, well, I think 3 large oval spots at one time. I could see I could see a very, very narrow cloud band on the planet's atmosphere right across the equator, as well as the equatorial cloud bands on either side of the equator, which are fairly wide. So it did very well. The telescope is just amazing at looking at the moon and the planets. There are all kinds of subtle details on the moon and the craters of the moon. I managed to see the moon under fairly good observing conditions when it was around first quarter moon about a month ago. And there was all kinds of very, very subtle details in the craters and shadings here and there, little rills, all kinds of stuff all over the moon with this telescope. It was just amazing. So I got all kinds of plans for this thing. As I say, this thing, the entire telescope weighs, with a heavy eyepiece like that in it, that's about 5.6 ounces, that eyepiece, or something like that. The telescope weighs just a little under 12 pounds, which doesn't sound like much, but it is a chore for me to carry it up the steps. Sometimes I take all the eyepieces out of the telescope, including the 3 spare eyepieces there, when I go to carry it into the house at night. It just takes a few extra seconds to take those out, and that reduces the entire weight of the telescope by approximately 1 pound, which doesn't sound like much, but it makes it significantly easier for me to carry that telescope into the house when I'm finished observing. Actually, there's a plate that goes over top of this that came with the telescope. It's actually a dew cap, it's actually a dust cap that goes over the corrector plate, and it keeps the dust off there. And it's so difficult to maneuver. This is a permanent dew shield that doesn't come on and off, and it's almost impossible to put that dust cap on there that came with the telescope when you're storing the telescope. So what I do is I just store it in a horizontal position like this when I'm not using it, and when it's being stored, and I do not put the dust cap back on. I just leave it off, just like you see it. And I put a large plastic clear garden bag, a huge one, right over top of the whole telescope. And that keeps the dust off the whole telescope and everything when I'm not using it. And it comes off in just a few seconds if I want to take the telescope out. It's actually safer for the corrector plate to leave the dust cap off when you're not using it. Just leave the thing right off with that cardboard dew shield on there. And it's a little tricky for me to get that corrector plate or the dust cap on and off that thing even without the dew shield on there. So this is a really good way to store the telescope, just like that in the horizontal position. And then the dust doesn't, and I usually leave the diagonal mirror like that in a horizontal position so that any dust trapped in there will not settle on the mirror. By the way, cleaning the lenses off, I got a special lens brush from actually it was from Future Shop when they still had their stores open, and I use that to dust the dust off very, very gently off the eyepiece lenses once in a while, and off the corrector plate. And that's got special fibers on it that are almost guaranteed not to scratch the lens. So that's a really good way to keep the lenses clean, and you don't have to do it all that often either. And if you keep the eyepieces out of the dust when you're not using them. Another thing is to avoid putting fingerprints on the lenses. You don't want any fingerprints on those. There are instructions on the internet on how to clean fingerprints and greasy spots off camera lenses and off telescope lenses and eyepieces and mirrors and stuff like that without damaging the optical surfaces. So there's all kinds of really detailed instructions on how to do that. So I thought I'd mention that. So anyway, also I should mention that if you take this telescope outside on a cool night, what happens is that from going inside to outside, the telescope tube is a little bit warmer, and it takes a while to reach thermal equilibrium with the outside air. And until that happens, your views of the moon and planets are going to be a little bit fuzzy. They're not going to be very sharp. But after about half an hour to an hour, if the temperature difference is not too great from the indoors to the outdoors, after half an hour to an hour, the telescope will reach approximate thermal equilibrium, and all of a sudden your images will be as sharp as a razor. So there's a lot to learn about that sort of thing. This little telescope right here, actually, an ordinary achromatic refractor has the same problem, but it's not as severe as this kind of telescope right here, because this has lenses and not mirrors. And without going into a lot of detailed explanation, this telescope right here reaches thermal equilibrium much more rapidly than that telescope. And so if you're in a hurry to take a look at the planets, you'll probably actually get a sharper view of the moon and planets with that telescope on a cold night than you will with this one. It's really amazing to think that that little telescope that cost $130 plus the cost of that little lightweight tripod would do that. I guess I mentioned to you that I reoriented that lever so that it would be aiming upward when the telescope would be aiming upward, and that way the telescope can aim almost straight overhead in the sky. It just might bump into the legs once in a while, but that can be easily taken care of by rotating the whole telescope around. And this lever would, as you could see, it would quite easily bump into these legs if you tried to aim the telescope up too high. Another little feature of this tripod I can mention while I have some more video room. I don't know whether it'll focus in very well on this. I think it will with the zoom lens. I'll zoom in another. I think you can see that fairly clearly. Whether the autofocus will work that well. There is a bubble level like there. So if you're on an uneven surface, you can actually use this little level here. I don't know whether you can see that well. I'll try and hold the camera really steadily for a minute. This little bubble level right there will allow you to fairly accurately level off the tripod so that it'll be less likely to tip over and that sort of thing on uneven ground. So that gives you a quick way of, you can actually level the tripod by simply adjusting these tripod legs. You just unclamp that thing that's got a quick clamp, and you can lower and raise one of these legs a little bit. You have to get a good grip on the tripod to make sure you don't let go or something, because it slides around pretty easily. Then you clamp that when you get that bubble right in the center. Another thing too is that if you want to aim, I found this with the other telescope when I was using it. It's a very handy thing to know. It's kind of hard to adjust the altitude in small amounts with that clamp. What I found is, when I'm sitting down looking through the eyepiece, if I have one of these legs facing toward me so that when I'm looking through the telescope I can easily reach this device, all I do is move this. If I want to raise the telescope up and down slightly, all I do is loosen this, just flick it back like that, and it loosens the thing, and then I can slide this leg up and down in this device very, very small amounts, a millimeter at a time, and then clamp it. And that actually serves as a rather crude, very effective slow motion control, allowing me to change the altitude direction of this telescope in very small amounts. It's a very handy feature to have. Another thing I've got is in my house somewhere I've got a special device sold by Orion Telescopes and Binoculars. It's a little device, a little square metal object right there that fits in between here and the base of the telescope tube like this. I'll aim the camera a little better with the thing zoomed out a bit. The object clamps right in here like this, and what it has is it's got slow motion controls on it, which is really a handy thing to have, but it adds another pound or so, maybe, or almost a pound to the weight of the telescope, and it makes this tube very unbalanced because it shifts it about maybe 2 inches farther out that way, away from the center. And so if you want a slow motion control that's very convenient, all you do is clamp it really tight, and then this you can use the camera tripod controls to get an approximate direction, and use the slow motion controls on that to move the telescope around up and down and sideways in small amounts. So anyway, that's about it. I think this video is over with. I'm going to crunch it right now. Here it goes. Goodbye, everybody.